Hello students. Today we will start a new lecture. We'll continue our lecture series on the amino acids. And today's lecture will be amino acids part 2. In this lecture we'll learn about the nine hydrophilic amino acids. There are 9 of these. And we'll learn the structure of these amino acids. I'll give you some tips to help you remember how to draw them, because you'll have to know how to draw these amino acids, because they're not only found in proteins, but they're also involved in biochemical metabolism. The first amino acid is going to be serine. Let's just list these amino acids. Serine is going to be the first one that we will learn. Then we'll move to threonine. That's the second hydrophilic amino acid. Our third hydrophilic amino acid is cysteine. Cysteine is involved in disulfide bridges in proteins. The next one is going to be aspartic acid. And now, there's something unique about these next 4. If you can just remember one structure, it's going to be easy to remember these next 4. Aspartic acid is very closely related to glutamic acid. There's only one methyl group that between them. And glutamic acid, aspartic acid, is also closely related to asparagine. All you have to do is add an amino group, and you will get asparagine. And again, asparagine is also closely related to glutamine, just the methyl group. So those 4 will go together. So all we have to do is remember one thing, and we can remember those 4. The next amino acid is going to be histidine. And histidine is, the amino acid histidine is involved in the production of histamine. They sound alike. And so histidine has this imidazole ring in it. And we'll learn what an imidazole ring is. And the last of our hydrophilic amino acids is the amino acid arginine. I've not come up with a trick or a method to help anyone learn the structure of arginine. It's just one of those amino acids that defy ease of drawing. It is the most difficult of all of the amino acids, and we'll probably spend a little time, more time on arginine than any of the amino acids. It does have a very special functional group in it called a guanidium group. It's a propylguanidium, and that's the only way. I don't know how to associate that with arginine. I guess you just have to remember that propylguanidium goes with arginine. And so here we are, the 9 hydrophilic amino acids. I hope this lecture is of benefit to you. Our first hydrophobic or hydrophilic amino acid is going to be serine. The first thing we want to do, as before, is identify the parent compound of the side chain. So let's draw that here for serine. That parent compound is going to be CH3OH. And this, of course, is methanol. And serine follows the methyl attachment rule, so it's easy to see that for methanol, for serine, the methyl group is going to attach to the alpha carbon. So let's now draw the structure of serine. NH3 here. And we're going to have a charge here. Our alpha carbon with its hydrogen. The carboxylic acid group. And CH2OH. There's our methanol group. And this is the amino acid serine. Now the only thing that we need to do is create the association, some sort of association in our mind between serine and methanol. Now I've come up with a sentence. Let's do something here. Let's move me up a little. Straight up here. Very good. And now I'm going to type this sentence here. Doesn't want to give it to me. Okay, here it is. And you can just remember methanol causes, well, I'm going to just, because we're going to use the actual word, methanol causes serious blindness. Methanol causes serious blindness. So let's just make that a little bigger so we can always see that. So if you can remember this statement, you'll always be able to associate methanol with serine. Okay, again, a little review here. Methanol is a side chain of serine. Serine follows the methyl attachment rule, so the alpha carbon attaches to the methyl group. And the sentence for our association is methanol causes serious blindness. And of course, methanol should be easy to remember. I mean, there's methanol, that's the parent compound, and serine from serious. And this is our first hydrophilic amino acid, serine. The next amino acid is going to be threonine. And as before, we will start with the parent compound of the R group. And for threonine, that's going to be ethanol. Ethanol. This is the alcohol you drink. So let's just draw, let's put ethanol here. CH3, CH2OH. This is ethanol. We'll put the name here. ETHANOL. Ethanol. This is the alcohol you drink. There's ethanol. Okay. Now, threonine is one of the exceptions. VIT. It's one of the VIT exceptions. So let's put here VIT. It's an exception. And so here we have the methyl group. This is the methyl group here. I'm going to put the methyl group is going to be in red. The methylene group is going to be circled with blue. If it were to follow the methyl attachment rule, then the alpha carbon would attach to the methyl group, the red one. But it does not, so the alpha carbon is going to attach to the methylene carbon, the CH2. So now let's draw the structure of threonine. Let's put our carbon here. Our amino group, NH. 3 of these, and it's going to be protonated. The alpha carbon with its hydrogen, the carboxyl group, carboxylic acid group. And now I'm going to make this a little simpler here. I'm just going to grab this. It's going to probably get a lot of things. Nope, it's going to be too much. It's trying to get too much. Let's just draw it over. Okay. Now let's just redraw it here. We're going to have our CH, our methylene carbon here. It's just going to be 1 there. And our OH and our CH3. And this amino acid is threonine. Threonine. not a difficult one. You just have to remember for threonine, it violates the methyl attachment rule, and it's one of the 3 exceptions, VIT. So we need to make an association now between threonine and ethanol. This one was tougher. This is a tough one for me. So I've come up with an association, but it's like a double association. So it's a little more difficult. So I came up with this. The student drank 3 beers. And now you just have to remember, oh, okay, beer has ethanol in it. That is the alcohol in beer. And so you have to make that connection and say, oh, so 3 goes with ethanol. So this is a tough one. This one is a little tougher, but if you can remember, you're good. The student drank 3 beers, and beer has ethanol in it. So I'm going to actually put that in parentheses. And if you can remember this statement, you'll always have an association between threonine, the amino acid, and its parent the parent compound of the side chain, ethanol. And this is the amino acid threonine. Hope you remember it. The next amino acid is going to be cysteine. Now let's start with the parent compound. That parent compound is going to be, I'm going to draw its structure first. Just going to draw it first. CH3 SH. Now if that were CH3OH, it would be methanol. Methanol. If it were CH3OH, it would be methanol. But when you replace an OH with an SH, you change it from an alcohol to a thiol. So the name of this compound is methane thiol. Methane thiol. And that's our parent compound. Methane thiol. Okay. Let's just move it up out of the way. Let's put it up here for now. Okay, so there's methane thiol. I wish... Okay, don't try to do too much. Okay. Now, there's only one methyl group, so we don't have to worry about the methyl attachment rule. Now let's draw the amino acid cysteine. So we're going to put our amino group here. Our alpha carbon with its hydrogen. Our carboxylic acid group. And now we're going to attach methane thiol to this amino acid skeleton. So we're going to have our methyl group is going to attach here, CH, now it's 2, and now SH. And this is the amino acid cysteine. Really simple one. You just have to remember methane thiol. That's the tough part, methane thiol. That methane thiol is a little difficult to see, so I'm going to do something for myself here. Okay, perfect. And let's send this back. That's a little better. Methane thiol. Now we need to come up with some sort of relationship or some sort of association between cysteine and methane thiol. let's use this sentence. I'm just going to write it. What was it? My sister has metal in her thyroid. My sister. I'm not going to write it. That's too long to write. My sister. Ooh, this is a tough one. How are you going to do it? How are you going to do sister? Well, you're going to have to just spell sister. My sister has metal in her thyroid. Okay, my sister has metal in her thyroid. And you just have to remember this. This is a pretty good, well, I'm not the one to say that. You'll have to be the one to say if it's a good association or not. Sister, cysteine, metal, thyroid, and that's methane, thiol. My sister has metal in her thyroid. And this is the amino acid cysteine. Hope you remember it. The next amino acid is going to be aspartic acid. Aspartic acid kind of goes along with three other amino acids: glutamic acid, asparagine, and glutamine. And so we're going to kind of do the four of them together. Because if you can get just one of them, you can make easy connections to the other three. And so let's start with aspartic acid and get the parent compound of its side chain. And that parent compound is going to be, here we are. Okay, that parent compound is going to be CH3 COOH. Now this is acetic acid. And this is vinegar. Acetic acid. And so if we wanted to draw now, aspartic acid, this is a very simple task now. NH3, the alpha carbon, its hydrogen, COOH, and CH2, COOH. And this compound is aspartic acid. Now, again, remember, aspartic acid and three other compounds are very closely related to one another. We're only going to make two changes. We're going to either add another carbon, or we will aminate the carbonyl carbon. Okay. And so, but let's make an association with this one first. Okay. Let's insert myself a text box. And let's use this sentence here. Aspirin is dissolved by vinegar. And you can just imagine yourself dropping an aspirin in vinegar and it dissolving. But you just have to remember that vinegar is acetic acid. if you can remember that one statement, that will help you with 4 amino acids. Aspirin is dissolved by vinegar. Okay. And so here, aspirin, if I can just put this here. Oh, that's, wow, did not realize that. Aspirin will help you remember aspartic acid, and vinegar will help you remember acetic acid. So aspirin is dissolved by vinegar. This is the amino acid aspartic acid. I'm going to do the next one now while I'm here. So I'm going to actually copy. I'm going to copy this. Okay, I'm going to copy this here. I'm going to go to the next page where we have glutamic acid. Okay, I'm going to paste that here. Now what I'm going to do, I'm going to erase everything I don't want. It would actually be better. I'm going to undo that. Okay, I'm going to undo all of that. And what I'm going to do, I'm just going to copy this. Control D. I'm going to make a copy of this. So I'm going to change this now to glutamic acid. Okay. So glutamic acid. I'm going to get rid of this. And now I'm going to erase all of this we don't need for acetic acid. Okay. Now this is going to be perfect. Now we have the amino acid. So I'm going to group all of this together here. Make one big unit out of all of this. So this is our amino acid. This is aspartic acid here. So now we're going to, what do we have to do to turn aspartic acid? So I'm going to put under here ASP. So this is aspartic acid. Now I want to convert aspartic acid into glutamic acid. And this is the easiest way to learn this amino acid, is just to do it this way. This. All we have to do is add another carbon. And so here we have, instead of putting the carboxyl group here, what we're going to do is get rid of this, add one more carbon here, CH2, and now put our carboxyl group, COOH. And now this amino acid is glutamic acid. Very simple thing to do. And so now we have the amino acid glutamic acid. Now there's no association to remember. Just remember, add one more carbon to aspartic acid for glutamic acid. Let's do one more. We're going to learn 2 amino acids on this next slide. So I'm going to make a copy of this. Okay, this is a copy now. And so what I'm going to do, I'm going to put not glutamic acid. This is going to be asparagine and glutamine. Okay. Let's do both of these here. So this is glutamic, this is aspartic acid. Aspartic acid is here on the left. Glutamine is here on the right. Now all we have to do now to convert aspartic acid into asparagine we'll just do, make sure I don't miss this here. Where's my sheet? So I want to make sure I don't want to have to redo this. Okay, all we have to do to convert aspartic acid, into asparagine is remove the OH. I'm going to get rid of this. We're going to remove the OH here, and now we're going to replace it with an NH. NH2. And now we have asparagine. And that's pretty easy to remember. Asparagine. And now to convert glutamic acid into glutamine, just do the same thing. Just remove the OH and replace it with NH2. So now this is no longer glutamic acid, it's now glutamine. And that's 4 amino acids you can learn from just one statement. Aspirin is dissolved in vinegar. And now all you have to do is just remember, okay, which one do I add the carbon to? Which one do I add the NH2 group, the amino group to? If you want to remember, it's still good to know what those parent side chains are. And so this parent R group here, I'm just going to draw the parent R group up here. It's going to be CH3, CO, NH2. This compound is called acetamide. Let's get a better color there, something that's going to stand out. acetamide. Acetamide. That's the parent. That's the R group. And over here, glutamine, the parent compound. Doesn't want to work here. So the problem is, okay, the parent compound is going to be CH3, CH2, CO, NH2. And this compound is propanamide. It's still good to know what that R group is, even if you don't remember it going through this method. So propanamide, that's the R group for glutamine. Now let's go back to our previous slide, because there's one R group we didn't identify. For aspartic acid, its R group here, let's circle it with green, its R group here, we'll put it up here, CH2, COOH. This was acetic acid. We already named this one. Okay. And the R group here is the same. It just has one more carbon on it. I'm going to actually get rid of, well, I can put it right here. It's going to be CH3, CH2, COOH. This is propanoic acid. So when you aminate acetic acid, you get acetamide. When you aminate propanoic acid, you get propanamide. And those are the next 4 amino acids: aspartic acid, glutamic acid, acetamide, and propanamide. No, asparagine and glutamine. Those are our next 4 amino acids. Hope you're okay with those, because those were kind of tough. The next amino acid is going to be histidine. And as before, we're going to start with the parent of our R group, and that's going to be a derivative of imidazole. So let's draw imidazole first. It's a heterocyclic ring. Okay. Okay. So imidazole is going to look like this. C, C, N, N, C. And just join them together. Put a double bond between the C's and a double bond between the N and another C. Either one of them, it doesn't matter. And give the other N and H. 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 And H. And this is imidazole. Okay. But that's not the compound. So what I'm going to do, I'm going to draw imidazole another way. I'm going to just draw it like this. I'm not going to draw the carbons explicitly. I'm just going to draw it like this. And this is imidazole as well. But again, this is not the compound that's found. Okay, let's see if we can just grab this. Nope, it's not going to let me grab just that, so I'm going to have to grab everything. I'm going to grab everything and just make a copy of everything. Okay. Okay. And so this is imidazole, and we have imidazole over here. Wish I could change the color of that. I don't think I can though. Nope, cannot change that color. Okay. Now, all we have to do here is add a methyl group to this. And now this is no longer imidazole. So we have imidazole on the left, and we have methyl imidazole. Methyl imidazole on the right. And methyl imidazole is going to be the parent of our R group. And so now, let's make our amino acid histidine. Histidine. And so there's a lot here. So we kind of need to make all of this smaller, because all of this is like in our way. So what I'm going to do, I'm going to do this. I'm going to grab this here. Let's make sure that's grouped. I'm going to put it all together. I'm going to group all of this, and I'm going to make it smaller. Okay. This is imidazole, which we don't really need anyway, because it doesn't help us. And then here is methyl imidazole. Okay, we're going to group all of this together. There we are. Okay, we're going to make it smaller. And this is the one we need, methyl imidazole. Okay, we're going to take a methyl imidazole and put it here. Okay. Now let's draw our amino acid, histidine. H, 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 protonated, alpha carbon, H, carboxylic acid group, and now methyl imidazole. I'm going to make methyl imidazole another color so it can stand out. CH3, N, I'm going to put out my double bond in the same place as before, my H here, So methylamidazole. And so this is our amino acid histidine. Okay, now we have to create some sort of association between histidine and methylamidazole. And as you can imagine, that's going to be kind of difficult. But I have come up with one. I hope it makes sense to you. Let's see here. His problem with a B, his problem was met with an immediate solution. Okay, and this is our sentence. His problem was met with an immediate solution. And you have to use your imagination on this one, unfortunately. You're going to have to be very imaginative. His is going to be histidine, methyl, imidazole. Immediate solution is going to be imidazole. And I know that's a tough one. That's a tough one. That's a stretch there. But here we are. His problem was met with an immediate solution. If you can remember that, you'll have an association in your mind between histidine and methylamidazole. This is the amino acid imidazole. Hope you can remember it. The next amino acid is going to be the amino acid arginine. Now, the parent group for arginine has two chemicals, almost has two components to it. The first one is going to be guanidine. So let's draw the structure of guanidine. Okay, guanidine has the structure CNH2 NH, and actually I want to change that. I don't want to put my double bond here. So this is going to be here NH2 and then the double bond NH. And this structure is guanidine. Okay, it doesn't want to write guanidine for me here. Let's make sure we have a pen. I think the computer's having some issues right now. It doesn't want to draw guanidine for me. Let's see if it'll give me this. Let's go back to the pen. Guanidine. Guanidine. And so this structure is guanidine. Okay. There's another structure you'll need to know. A relative of guanidine. Let's see if we can put all of this together. Oh, great. And so let's group this here to make one structure. Okay. Now I'm going to make a copy of my guanidine here and put it over here. So let's do something here to guanidine. What we're going to do is we're going to add another hydrogen here, and so that's going to give us just a charge. And so now this is not guanidine, this is the guanidinium ion. The guanidinium ion. Okay. And this is what's really found in arginine. So arginine has a guanidinium ion attached to something else. And let's figure out what that something else is. So let's grab everything here. Let's kind of make all of this smaller. So we need that guanidinium ion. maybe we need to group it first. Let's group all of this and now make everything smaller. Okay, so let's just put this to the side for now. And also in arginine, we have just regular, we have a propane group here. Ooh, you can't, I noticed with these, you can't really undo. It doesn't like it when you undo. So we're going to have CH3, CH2, CH3. Attached to that guanidinium ion, we're going to have propane. This propane is just a linear, well, it has to be linear, but it's just a three-membered alkane, three-carbon alkane. So we're going to have the propyl guanidinium ion. So let's draw all of that. I'm going to put my propane here. I'm going to go to something else. I don't know why you have to kind of do something else to make them separate. So let's draw propane, CH3, CH3, CH2, CH2, NH, C, NH2, and NH2 plus. And so this is the propyl guanidinium ion. Propyl guanidinium ion. Okay. And this is the R group for arginine. Okay. Now let's draw the whole amino acid, the entire amino acid arginine. Let's see if we can get all of this. It won't let us have all of it. So I'm going to move the propyl guanidinium ion to the side. Let's group it all together. Let's make it smaller here. I don't know where I can put it. Maybe I can put it here. Okay. There's a propyl guanidinium ion. Now let's draw the entire amino acid, arginine. Okay, we're going to have our amino group in HHH plus the alpha carbon with its H, the carboxylic acid group, and now for propane, or doing propyl guanidinium ion, CH2, 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 NH, C, NH2, double bond, NH2 plus. And this is the amino acid arginine. So now we need to come up with some sort of association between arginine and the propyl guanidinium ion. Okay, and let's see what sentence I have here. Okay, and we'll put our sentence right here. This looks like a good place for it. Argentina proposes Guantanamo Bay closing. Argentina proposes Guantanamo Bay closing. Okay. This is going to be our, okay, let's make this bold. Let's fill it with a color that makes it stand out here. And now let's just make it larger. Argentina proposes Guantanamo Bay closing. And so if you can remember this statement, you can think, well, Argentina Argin is arginine. Proposes propyl guantanamo guanidinium ion. Okay, and now for those of you who may not know what Guantanamo Bay is, the U.S. Navy in Cuba has, let's see here, this needs to be on the top. Let's move this to the front. Okay, this is the island of Cuba. On the island here, we have the U.S. has a U.S. naval base called Guantanamo Bay, and on that naval base, they put terrorist prisoners. Okay, and shown here. Let's undo that. Well, I'm gonna have to do this. Okay, and now I need to get this back. I hope it's in the center. Very good. And so here we have, these aren't real Guantanamo Bay prisoners here. These are just protesters, and they're pretending like they're they're like terrorist prisoners, but they're not. You see, close Guantanamo. They want Guantanamo Bay closed, the prison part of it. And this is Amnesty International. And so this may help you remember this statement. Argentina is just another country, and they are proposing that Guantanamo Bay be closed. And this is our last hydrophilic amino acid, arginine. Hope you can remember it. On this last slide, we're going to summarize our 9 hydrophilic amino acids, and we're going to create a table that will help us to remember, and really it'll just summarize those 9 amino acids. And on this table, we're going to put a few things here. We're going to first put the amino acid, the parent of the R group, and our association phrase. Now I typed these when I was creating the slides. I typed these so I was able to copy and paste them into a Word document. And I'll just be able to paste those, so I won't have to type them over again. Okay. Now the first amino acid was serine, and the parent of the R group was methanol. And our association phrase, I'm just going to go here and copy this. Methanol causes serious blindness. Our next amino acid was threonine, and the parent of the R group was ethanol. And our association phrase, the student drank 3 beers, and you have to remember that beer is made of ethanol. The alcohol in beer is ethanol. Third amino acid was cysteine, or cysteine. The parent of the R group was methane thiol, almost like methanol, but it has an S, so it's methanethiol. And our association phrase was a tough one. My sister has metal in her thyroid. Sister is for cysteine, metal, methane, thyroid, thiol. That's a tough one. The next amino acid was aspartic acid. And the parent of the R group is acetic acid. And our association phrase was aspirin is dissolved by vinegar. And aspirin, aspartic acid, acetic acid, vinegar, you have to remember vinegar is acetic acid, and so that's the parent of the R group. Now, one thing you want to remember about aspartic acid, there are three other amino acids that are very closely related: glutamic acid, asparagine, and glutamine. So once you get aspartic acid, you can easily get to glutamic acid by adding another carbon. You can get to asparagine by aminating the carbonyl carbon, and you can get to glutamine by doing both of those from aspartic acid. The next amino acid was histidine, and the parent of the R group is methyl imidazole. And the association phrase is another. His problem was met with an immediate solution. That's a tough one. So histidine met methyl immediate solution is imidazole. That's a tough one. And our last amino acid was arginine. And the parent of the R group is propyl guanidinium ion. Hope that's spelled right. And the association phrase is Argentina proposes Guantanamo Bay closing. Arginine proposes Guantanamo, propyl guanidinium ion. And so these are, well, I can just turn spelling off. Let me see if I can turn spelling off here. Ignore. Okay. Let's just do okay. Maybe it'll turn all the spelling off. Very good. Close. And so, there we are. Our 9 hydrophilic amino acids. And that concludes this lecture.